Hi guys, in this video we're going to start with a quick review of what you already learned about greatest common factor. So we're going to start with a couple examples. As we're working through this video today, please make sure you have a piece of paper and a pencil on your desk. I'm going to ask you to copy down at least one of these examples, and this will serve as your notes for today. So when you're asked to find the GCF, or the greatest common factor, I'm asking for the largest number that could be divided into both of these terms evenly. So we're going to use what we call the cake method, and the reason I call it that is because when you're done, it will look like a very nice upside down cake. So what we'll do first is we will take the two numbers I'm finding the GCF of, and I'm going to write them side by side, and I'm going to draw my first layer of cake just like this. And I want to think to myself, what number can be divided into both of these numbers evenly? And knowing that they're both even, I'm going to choose 2. If I divide 16 by 2, I end up with an 8. If I divide 48 by 2, I end up with a 24. And so what I've done is I now created a second layer of cake. So I'm going to draw my second layer. Now I'm looking at 8 and 24, and I want to figure out another number that goes into both of those evenly, and 4 jumps into mind. So I divide 8 by 4, that gets me 2. 24 divided by 4 gives me 6. And I'll add another layer to my cake. 2 and 6 can both be divided by 2, so I put a 2 on the side. 2 divided by 2 leaves me with 1, and 6 divided by 2 leaves me with 3. Looking at 1 and 3, the only number that those can both be divided by is 1. And so once I run into that, once I put a 1 here, that tells me that the problem's over. And what I do to find my GCF is I multiply together all the numbers on the outside of the cake. So 2 times 4 is 8, times 2 is 16, times 1 is 16. So in this problem, the GCF is 16. Let's try another one. So I'm going to start off again with the two numbers I'm finding the GCF of. So we have a 12 and a 30. And I will draw my first layer of cake. Now 12 and 30 I know can both be divided by 6. So I'll put a 6 outside. 12 divided by 6 is 5. 30 divided by 6 is 6. And this is going to end up being a very tiny cake because I'll go ahead and draw that second layer. 5 and 6 don't have any other common factors other than 1. So if I multiply those numbers down the side together, 6 and 1, I find that my GCF is going to be 6. So what I'd like you to do is pause the video, try these 4, and then when you're ready to check your work, go ahead and press play. Welcome back. So the correct answers are as follows. Number 1, you should have got a GCF of 6. Number 2 is 30, number 3 is 14, and number 4 is 18. We're going to add a little bit of new stuff to this now, so I'm going to be asking you to find the GCF of a monomial. And a monomial is a fancy word meaning one term. And the type of terms that you're going to be see in these problems is something such as 4xy, or 20ab, or 3c. And you'll notice that there's numbers included, there's variables included, and they're being joined together through the operation of multiplication. So I know it sounds a little wacky, but we're going to find the GCF of these monomials. And the cool thing is I start off just the way I did before. I put the two terms in the top of the cake, and we draw our first layer. And I'm actually going to ignore the variables at first. Looking just at my numbers, 14 and 32, I know that they're both even, so I'm going to divide them by 2. 14 divided by 2 leaves me with a 7. 32 divided by 2 leaves me with a 16. And what I do here is I just bring down that variable, and we'll draw our next layer of cake. Looking at my terms 7 and 16, they don't have any other common factor than 1. So now I move on to the variables. And I'm looking for a variable that occurs in both terms. And I see that x is occurring in both terms here. So I'm going to pull out that x. Now, if 7x had one x in it and I took it away, I'm going to be left with a plain 7. If 16x had one x in it and I took it away, I'm going to be left with 16. And I'll draw my next layer of cake. As we said before, 7 and 16 don't have any common factors other than 1. So just like before, I'll multiply together the terms on the outside here, and that will give me my GCF. 2 times x times 1 is 2x. Let's take a look at another one over here. So we have 34ab and 70abc. Again, I'm going to ignore the variables for just a moment. We'll make our first layer of cake. Whoops, that was a highlighter. Oh well. So 34 and 70, they're both even. We could divide them by 2. 34 divided by 2 is 17. I carry down the variables. 70 divided by 2 is 35. Again, carry down the variables. I'm going to add another layer to the cake. Looking at 17 and 35, they don't have anything in common. So I'll look at my variables and I see that I have an a in both terms. So I'm going to pull out an a over here. If 17ab had one a in it and I took it away, this is now 17b. 35abc had one a in it. It's now 35bc. I'll add another layer to the cake. And the next thing that jumps out at me is that both terms have a b. So I'm going to pull the b out. If 17b had one b and I took it away, I'm left with 17. 35bc had one b, I took it away, I'm left with 35c. We're going to add another layer to our cake. If I multiply those terms on the side now, 2 times a times b, I find out that the GCF is 2ab. So just like before, I'd like you to pause the video, try these 4 questions, and go ahead and press play when you're ready to see the correct answers. For number 1, we should have 2a. Sorry about that. Number 2 is 8x, number 3 is 3ab, and number 4 is 6b. Nice job with this. Next up, we're going to learn about factoring expressions.